Thank you, Mr. Toastmaster, honored guests. Tonight, I have the opportunity to talk to you about a subject which is really close to my heart. A couple years ago, when I matriculated to medical school, I did so with the intention of becoming a physician scientist. And that is a doctor who not only sees patients, but does translational research in the laboratory and is able to take the scientific knowledge from the laboratory into patient care. And as I've gone down my training pathway, I've become more and more unsure of what I'm doing, if this is the right thing for me, if the scientific paradigm that we use in the United States and in other developed nations is actually functioning the way that it's supposed to. Here's something for thought. Since the early 1970s, when the war on cancer began, over $100 billion has been spent on basic laboratory studies. These include investigations of cell lines, of animal models. These are studies that are done in the laboratory before a drug becomes mature enough to become tested in human subjects. And yet, here we are in the year 2015, and cancer has overtaken heart disease as the #1 cause of death worldwide. There are a number of problems to point to for why this has happened, but from my perspective as a student of translational research, preclinical science has much to blame. Not just over a year ago, a very powerful pharmaceutical company called Amgen did what is now a famous study. They tried to reproduce the results of 53 papers in cancer research. These were the most impactful breakthrough studies that had been published in the past 20 years. These studies were published in journals like Science and Nature and Cell, the pinnacle of attainment for the scientific community. Of those 53 papers, the scientists at Amgen were able to reproduce 6 studies. I'm being quiet just for a second to let that sink in. When you think about the hundreds and hundreds of studies that have been built upon this core subset of 53 major breakthroughs, it seems like so much effort has gone to waste, so much valuable time and resources. So what is driving this insanity? Well, I believe that there are 3 very big issues. Reproducibility of data is certainly one of them. The fact that science in the United States is no longer hypothesis-driven is another. And finally, is that science has become a very insular prospect, with multiple small labs doing very similar research and competing with each other instead of sharing ideas and data. So let me talk a little bit more about reproducing data. When you're a professor or a graduate student and you're running a lab and the NIH is funding you and they want to see results, and you've done an experiment 50 times and it hasn't worked, and then one day you walk into the lab and you get data and it looks like positive data, the temptation is so overwhelmingly strong to ignore all that negative data and put it to the side and to present your positive data and say, look, here's my experiment. It worked. I can publish. I'm not going to lose my job now, and my lab can keep its funding. And that pressure is so enormous to keep pumping out papers instead of taking the time it takes to reproduce your studies and to consider all the variables to make sure that what you are presenting as your scientific research is actually truth. That care is less and less frequently taken. And the data shows this. Although there has been an explosion in the number of papers published in the last decade, the numbers of papers subsequently retracted has exploded as well. Secondly, science is no longer hypothesis driven. We all learned about in high school about the scientific method. You have a hypothesis, you have a new idea, a burning curiosity, you have an opinion and you want to prove that opinion wrong, you want to test it, you want to know more. And what science has become is a committee-driven endeavor by prominent scientists who like to take funds and put it to the most immediate use that they think could possibly produce data. It's no longer, let's test this innovative hypothesis. It's, let's do something slightly differently with this mouse model that we already have because we think that we'll get data from that work that we'll be able to publish and make a story out of somehow. We'll put some experiments together based on our funding, and then we'll come up with a hypothesis that we were supposed to have before we did the experiments. And scientists who submit innovative grants to the NIH, people with very new ideas that haven't been tested before, are being turned down for funding because the NIH is such a conservative institution. They feel so much responsibility that if they give a scientist money, there has to be valuable data that comes out of the work. And finally, as I already mentioned, science has become such an insular and competitive institution. You have these very small groups doing the same experiments, and in my own experience, it's actually quite common that somebody will withhold key information about their experiments to the scientific community because they don't want a rival scientific group to be able to pick up their experiments so easily and to be able to take over that work and thrive on it, because they want to feel protective of that because that's their livelihood in a competitive scientific environment. So I just want to thank you all for listening tonight, and I hope that after hearing me talk, you'll think about doing some reading on your own about what's happening in science right now and thinking hard about that, because in my personal opinion, the discourse in our country has become distinctly anti-intellectual and anti-scientific, and I really hope that we'll somehow be able to turn that around and make real scientific progress in the future. Thank you.